this session we are going to start with arrays. So in this session we are going to start understanding what arrays are, how to declare an array, how to initialize an array, how to access elements inside array, how to do bound checkings in array, passing arrays in function. We'll be touching a bit on multidimensional array. We'll be doing some sample questions, and we'll be doing some exercises. Like I'll be giving some exercises questions to you so that you can try it out and have more understanding on arrays. So let's get started. What is an array? Array is a type of data structure. Why we call array the data structure? Because it has a pattern of storing a data. Array stores a similar kind of data structure in a sequential manner. So if you are storing an integers in an array, the array will store all the integers in a sequential manner in a continuous memory location. For example, if you can see this example, here we have an array of integers where integers are stored in continuous location next to each other. 6, 7, 10, 32, 44, 5, 1, 4, 3. All these are integers which are stored in continuous memory locations, and this is called array. Array also has one more property, that it stores elements of same type. So array cannot have integer and float data type in a mixed fashion. You have to have only a single data type or same data type in an array. So how to declare an array? Array can be declared in this manner. First you need to give the data type, what kind of data you want to store in an array, name of the variable, name of the array, open square bracket, size of the array, and close square bracket. For example, if you want to declare an integer array, you need to say int, then you need to give the name of the array. Here the name of the array is numbers, then this is the size of the array. 10 is the size of the array. Similarly, if you want to have a float array, then give it as float, name of the array is values, and 5 is the size of the array. For characters, name is the variable name, and 6 is the size of the array. So how to initialize the array? So array initialization can be done in two ways. First, we touch about inline initialization. The inline initialization is shown like this. You can have array declaration, for example int numbers 10, where you are specifying that your array will be having 10 elements and you will be giving values. So you will be giving 10 integers. So each integer will be stored as shown in the first slide, like this. Each element will be stored like this. So first element will be stored at 0th position, second element will be stored at 1 position, third element will be stored at second position, and so on. Another type of initialization is where you don't give the size of the array. In this way, the array will automatically check or automatically initialize to the size of number of elements that we have given. So for example, we have given 10 elements here, so automatically the size of the array will be 10. For dynamic initialization, we need to do something like this. We have to declare an array. Say we have declared an array called ARR as an integer type, and we will be having a for loop, and for loop will ask user to enter the number, and that number will be stored in the array. One thing to point out is which is very important when we are learning the concept of array, is that every element in an array starts with 0, and the last element of the array will be size minus 1. Here size is the total number of elements in the array. So in this example, the first element is at the 0th position, the last element, which is the 10th element, is at the 9th position, which is 10 minus 1. So first and if we want to access third element, you need to give 3 minus 1, which is 2. So second position will be having the third element. So how to access an array element? Array element can be accessed with a subscript. A subscript is nothing but a number inside the square bracket. So suppose you have declared an array with ARR. So to access the third element of the array, you need to give ARR 2. So this will give you the third element of the array. So let's write a program to input 10 elements in the array and print it in a reverse order. Let's do some practical session. So here I am using Linux VI editor, vim array1.c. Let me give my file name as array1.c. Let's start with putting some documentation. Program to input array and print it in reverse order. Okay, let's include stdio.h. Let's declare the main method. Let's declare the main method as this, like this, and returning 0. Let's declare the array, say 10. Size of the array is 10. Let's declare one int which can be used as a loop counter. Okay, I'm writing one loop. So printf enter in position %d, which is say I. Okay, now to scanf %d ARR of I. Okay, so this will help me out in initializing my array. Now I'll be printing the array in reverse order. So before that, let me have some printf statement. And the next line, printing array in reverse order for int I equal to 9, I greater than 0, I minus minus. So this loop will be continued from 0 to 9. Then we'll be doing printf %d ARR of I. Okay, let's save this. Let's compile this. So compilation is success. Let's run this. Okay, it's asking me to enter the array at position 1. I'm saying 5 7 3 7 8 9 4 3 7, anything I can give, and this prints my array in reverse order. So if you can see, this is the order in which I have entered my number, and this is the order in which it is printed. So this is the mechanism of printing the number. It does not reverse the array, but we have printed array in reverse order. So bound checkings. In C, there is no check to see if your subscript used in array exceeds the size of the array. So as I mentioned earlier, uh, the arrays are stored in sequential in a continuous memory location. So in C we don't know, or there is nothing, any built-in function or any preprocessors provided to check whether the array size, what is the size of the array. So to do that, you need to do some manual coding. For example, you need to have some uh, variables saying size of the array, something like that, and you need to work around it so that you make sure you don't go beyond the size of the array. So in case you entered some subscript which is exceeding the size of the array, this will simply be placed in the memory location which is outside the memory location of array, and probably you will not get the proper data. It may give some unexpected results, or it may give some garbage value. It could lead your computer program to hang. Okay, so for example, if this is my array is of size 5. I have given numbers as 3 2 1 4 5. If I want to access ARR of 4, I'll be getting 5, because by giving this subscript, this is pointing to the last element of the array, and I'm getting. But if I say ARR of 5, which means it is the scope of this is outside the array, so I don't know what element what value it will pick. It will not give any error, but it will give some wrong value or some garbage value which is not useful for my program. So before working with array, you just make sure that you have proper you have things in place where you don't go beyond the size of the array. So pass by value and pass by reference. Passing an array to a function, this can be done by two ways: pass by value and pass by reference. Pass by value means we'll be having some function which will accept the type of data type, a single data type. For example, in this we are having an integer array, and we are having a function func, and this accepts integer type. Pass by value always passes the array or element of the array one by one. It does not pass the whole array. Pass by reference is using pass by reference, we can pass the entire array into the function. So if I have declared an array of size 5, and I have function func, and this function accepts the array, I can pass my array completely into the function and work accordingly. So the difference is like whenever I'm passing the complete array to the function using pass by reference, this function may change the content of the array, so we have to be very careful while working with pass by reference. So let's write some code for pass by value and pass by function. So I'm creating one file, array2.c. I'm giving some documentation example for pass by value and pass by reference. Okay, let me include stdio.h, and I'll having method declaration. Func1 will be passed by value. Func2 will be passed by reference. Okay, main. Okay, let me declare an array of size say 5. Okay, then I'll be let me have here I'm printing whatever I have received. %d. Well, now here I am using func2, defining it, reference size. So here I'll be having one integer for and having one loop. Okay, here I'm printing the values. Here it is like %d this is also pointer way of okay, this is the way of referring an array element using pointers. So in case you're not able to understand, just don't worry about it. We'll be covering this in pointer section, in section where we are doing pointers in C. But at this point of time, just see that this is how we'll be using it. Okay, now I'll be using this in the main function. Func1 arr of say I'm getting 3, and saying func2 arr of I'm giving arr and size is 5. Let me have a printf in between so that we will be printing this in a separate line, otherwise the output will not be very clear. So be putting next line so that okay, so received value 5, this is func1. Okay, and this is func2, where in func1 we are passing a value of third element of fourth element of the array, and in func2 we are passing the entire array. So this is the very minimal example of how we use pass by value, how we pass the array into function using pass by value and pass by reference. So multi-dimensional arrays. So what are multi-dimensional arrays? C programming language allows programmer to create arrays of array. So multi-dimensional array is nothing but arrays of array. What do you mean by arrays of array? Arrays of array is if you see this picture, here we are having 4 single dimensional array. This is one single dimensional array, this is one single dimensional array, this is one single dimensional array, this is one single dimensional array. So if we combine all those 4 single dimensional array, we will be having a tabular kind of structure, which is nothing but a multi-dimensional array, or in precise a 2-dimensional array. So in short, arrays of array will lead to a multi-dimensional array. Okay, so if you see, if you want to access the element, you have to access in row and column wise, where row will come first and column will come second. So this element is first element of the first array. That means first array will be always be the row wise, and which element we have to access will be column wise. So first row, if you want to access element in first row and third column, so it will always be first row, third column. This will be the this is how you can access. You need to give a of 0 and 3. So how to use multi-dimensional array? So we are covering 2-dimensional array here. In this program, this is how we can declare a 2-dimensional array. It's like integer, it's a data type array, and then we have to declare how many rows we want, how many columns we want. Okay, so for example, I am writing this main function. This is, I am declaring row as 5, column as 5. Now here I am declaring a 2-dimensional array. This 2-dimensional array will result in this 5 rows and 5 columns, and I can write 2 for loops. One loop will iterate through the row and other loop will iterate through the column, and I can initialize my array. Okay, so let's write a simple program to do this. I'm creating a file. Okay, let's start with documentation. Let's declare preprocessors, stdio.h, and let's write main function. Let's do return type. Okay, now let's define rows, say 3, columns say 2, array say row column. Okay, I am defining I and j. For I equal to 0, I less than row, I plus plus. Okay, this will iterate through the row. For j equal to 0, j is less than column, j plus plus. This will iterate through the columns. Then I say printf, enter the value at row %d, column %d, I, j, j scanf percentage d and of arr I j. Okay, now let's print this is how we can get an input. Now let's print it. For again we need two loops, I is then row I plus plus for j equal to 0, j is less than column j plus plus printf percentage d arr of I and of j. I'm adding a printf here. I'm adding an extra line so that okay, let's compile it, let's run it. Again it asks me the input. Let me give some values. Okay, so this is how it is printed. So this is my two-dimensional array of 3 rows and 2 columns. Okay, and the way to access is like this. It's a very simple program. So we have covered multi-dimensional array. So let's do some practice. We will solve some programs related to arrays. So let's write a program to print the largest and smallest element in an array. Okay, let's create a file. Okay, let's write program to print smallest and largest element in an array. Let me include stdio.h, stdio.h. Let me have main method, return 0. Okay, define the array. Let me define one array. Okay, let us take input from user. Printf enter value at position percentage d, which is I, scanf percentage d and of arr I. Okay, now I'll be declaring two variables, min, max. let me first find out the minimum element. Min equal to array. Let me initialize min element with the first element of array, I less than 10, I plus plus. So what we'll be doing is we'll be going through the array, and as and when we found any element which is less than min, we'll be assigning that element to min. So, and at the end of, once we complete the scanning of array, we'll be having the minimum element. Okay, so we'll be writing an if condition. If min is less than or arr I is less than min, then min equal to arr of I. Okay, similarly for max, again we initialize it with the first position of array. We'll be running a loop, then I plus plus. Now here we'll be checking if max is or arr of I is greater than max, then we'll be assigning max equal to arr of I. Okay, so this way we will be finding min and max. Let's print the result. Slash n min array is percentage d and max is percentage d slash n min max. Okay, let's save the program. Let's compile it. GCC minus o 4 4.c. Okay, program compiled successfully. Let's run the program. Okay, we need to give some values. Okay, I can give any value. So here it says that the minimum element in an array is 3 and maximum is 546. As you can see from here, it's very easy to find it out. So let's revisit the program. So here in the program we have used two loops, one loop to find the minimum element, one loop to find the maximum element. So let's put some thoughts on how to improve the program. So one way to do is not to use the two loops, but to make this condition also part of this loop. Okay, let's do this. I'll be writing max equal to arr max equal to min equal to arr 0. Okay, so if arr of I is greater than max, then max equal to arr of I. Okay, so here now we don't require this piece of code, so I'm commenting it. I'm not deleting it, but commenting it. Okay, let's compile it. Compilation is successful. Let's run it. Again, I need to enter some values. So here again I am getting the minimum element in an array is 4 and maximum is. So this is how we can improve our program. So let's do one more program. Write a program to print sum of all elements in an array. Again let's create so one file. Let's see, this will be finding sum of elements of an array including stdio.h. main. Let me declare an array, say 10. Let me initialize it so that we'll save some time. 534 this. So we have initialized the array. Let's cross check. We have 10 elements. 1 2 3 4 8 9 10. Yes, we have 10 elements. Now we have some counter, we have variable which says sum, initialize to 0. For I equal to 0, I is less than sum, sorry, I is less than 10, I plus plus sum plus equal to ARR of I. Okay, let me print it. The result, sum of ARR is percentage d slash n sum. Okay, this is a very simple program. Let's save it, compile it. Okay, compilations. Okay, we haven't forgot to give the output file. Let's compile it again. Okay, now sum of array is, let me clear the screen and run. So here we will get the sum of an array. So using this program we can see how to access the element of array and do some logic around it. Okay, so let's do one more program. Write a program to reverse an array. So here we are reversing the elements in an array. We are not printing the array in reverse order, but changing the elements inside the array. Okay, reverse an array. Let's include stdio.h. main method. Let me return 0. Okay, let's declare an array. Okay, let me declare it. Okay, I have declared an array. So what I will be doing is I'll be having two variables in front and rear. Okay, front will be at the first position, rear will be at the end of the array. So we'll be having one variable size temp. So we'll be exchanging front and rear element of the array. We'll be looping around it until and unless front is greater than rear. Got it? So we'll be having some while loop while front is less than rear. Okay, temp equal to ARR of front, ARR of front equal to ARR of rear, ARR of rear equal to temp. Here we are exchanging the values of front and rear. Now we'll increment front and decrement rear. Okay, now we'll print the array again for let's have an integer then I plus plus printf slash n percentage d. Let's have ARR of I. Okay, and this will give some extra space at the end of the program. So again I'll revisit the logic. We'll be having two variables. One is pointing to first element of the array, one and rear, which is pointing to the last element of the array, and we'll be having a loop until front is less than rear, and then we'll be exchanging the values of front and rear. So this and once we have done one exchange, we'll be incrementing front and decrementing rear. So first we'll exchange 4 and 58, then I'll increment front, so front will point to this, I'll decrement rear, so rear will point to this, then we'll exchange 5 and 6. I have not added comma, I have added dot instead. So let's do it again. Yes, compilation is successful. So this is the output of the program. We are accessing array from first element till last element, but we have reversed the array. So here we exchange the values of the array. So these are the exercise questions that you can try at your own place. These are related to two-dimensional array, but the concept is same that we have used in one-dimensional array. You can use same concept and write your code. First question is write a program to find the smallest element in two-dimensional array, and second question is this is a bit complex question, but just try it out. Just input 2 matrix and print the multiplication of the matrix.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.